Hey guys, Miss Whitehead here. Today you are going to learn the final method for solving a system of equations, and that's going to be our graphing method. So hopefully by now you have put this worksheet in your notebook. If you haven't, then that's fine. Go ahead and write on it now, and then when you are finished, please be sure to make sure that you place this in your notebook, whether it's glue it or tape it, whatever it is that you like to do. All right, so we've done solving by substitution, we've done solving by elimination. Now we're going to look at solving by graphing as our third way to solve a system of equations. So, starting out, step one is going to be put both equations in slope-intercept form. Okay, remember that from last unit, y equals mx plus b. All right, then it says graph both equations on the same graph. And then three possibilities can come up when you graph it. It says if the graph looks like this and the lines are intersecting, then let's see, hold on, let's draw some intersecting lines here. All right, so they intersect. Then you have one solution. If the graph looks like this and the lines are parallel, then you have no solution. And then it says when or why might the graph look like this? So when you graph it, it looks like it's just a single line. All right, that means that the two equations you have are the same line. And if they are the same line, then we say we have infinitely many solutions. So those are our three possibilities: intersecting, parallel, or the same line. One solution, no solution, infinitely many. All right, so now we are going to do some examples together. I'm going to do a few with you, and then when we get to the you try section, I'm going to have you pause the video, try these, and then come back and check your solutions once we get to that part. But we're going to do 4 of them together and to make sure that you understand how graphing works. All right, so if we go back to what we talked about last unit, then we are going to use the y-intercept and the slope to help us graph each of these lines. So if I start with this first one here, I'm going to go to 2 on the y-axis, and then I can go up 2 and left 3, or I can go down 2 and right 3 to get my 2 points. Maybe you have a straight edge that you can use. I'm just going to use this piece of paper here. It's the closest thing that I've got next to me right here at the time. All right, oh, that wasn't too great, but it'll work. There is our line for that one. And then we've got y equals -4. If you remember, y equals -4 is a horizontal line through -4. So a horizontal line through -4. So when I look at these two lines when they're graphed, I say, oh, look, they're intersecting, and they are intersecting at the point 3, -4. So that would be my one solution to this system of equations, 3, -4. That is the point where those two graphs intersect. All right, moving on to number 2. If I look at number 2, what's the problem? Oh, well, they're not in y equals mx plus b form. So that's the first thing I have to do before I can do number 2, is I've got to get each one of these equations in slope-intercept form. So if I start with the first one, I'm going to have to subtract x, and I'm going to get y equals negative x plus 4. And then if I take the second one, I'm going to subtract x, get negative y equals negative x plus 2, divide by negative 1, and I'm going to end up with y equals x minus 2. So these are the two equations that we're going to use when we go to graph each of these. So starting with the first one, if I go to my y-intercept, it is 4. So I go to 4 on the y-axis. Then my slope is negative 1. That tells me I can go down 1, right 1, or I can go up 1, left 1. Okay, and draw our line through those. Then for the second one here, I've got a y-intercept of negative 2. So negative 2 on the y-axis. And then my slope tells me I can go up 1, right 1, or down 1, left 1. And when I connect these two, I see once again they are intersecting. These two are intersecting at the point 3, 1. So that is my solution for number 2. 3, 1. All right, as we move on to number 3 has two equations that I've got to solve each of these for y first. So you can do this on the back of the sheet that you're working on, or if you want to go on a scrap sheet of paper. I'm going to come on a scrap sheet of paper and I'm going to solve each one of these for y. So minus 2x. I'm going to get 3y equals negative 2x plus 9. Divide by 3. And I end up with negative 2/3 x plus 3. So y equals negative 2/3 x plus 3. Then I'll do the same thing for the second one. I'm going to solve this one for y. Minus 4x. And that gives me 6x equals negative 4, excuse me, not 6x, 6y equals negative 4x plus 12. Divide by 6. Now negative 4 over 6, that reduces to negative 2/3. And then 12 divided by 6 is 2. So there's my second one, y equals negative 2/3 x plus 2. All right, now I'm going to go into graphing both of these. So starting with the top one, we'll go to our y-intercept of 3. And my slope tells me I can go down to right 3, or I can go up to left 3. And then the bottom one tells me that, oh, hold up, I think this should have been a minus 2 here. That was my bad, guys. I transferred it wrong. All right, so that should be a minus 2, because it was negative 12 divided by 6 is a negative 2. So then I go to negative 2 on the y-axis for my second one. Same slope here, so that tells me I can go down to right 3 or up to left 3. And hopefully, what do we notice about these? Hopefully you said that they were parallel. And if we go back up here, we said if it looks like this and the lines are parallel, then we have no solution. Right? The lines never intersect, so it's going to be no solution. Maybe some of you recognize from last unit where we did parallel and perpendicular lines that these two lines were already going to be parallel because they had the same slopes and different y-intercepts. If you did, great. All right. And last one we're going to do here together, number 4. So if I look at the top equation, I've got to solve it for y. So I'm going to pull over my scrap paper again, and I'm going to take that first equation there, and I'm going to solve it for y, so minus 2x. Right, so it gives me negative 2x plus 8, divided by negative 4. Right, you got a negative and a negative there. That's going to make a positive, and then you also have to reduce that. 2 over 4 is the same as 1/2. And 8 divided by negative 4 makes that a negative 2. So we ended up with y equals 1/2 x minus 2, and if we compare that top equation with the one below it, all right, we should see that this is the same exact line. They both have a slope of 1/2 and both have a y-intercept of negative 2. So when I go to graph these, it's going to look like I'm actually only graphing one line. So I start there, my y-intercept, negative 2. My slope tells me I can go up 1, right 2, or down 1, left 2. So when I graph it, it looks like it's one line, and we said if it looks like it's one line, that's the same line. So our answer is infinitely many solutions. That means those two lines will always touch each other the whole way across. So any point that's on that line is going to be a solution to this system of equations. If any of this went too fast for you, please feel free to go back and watch it again. Right? If you feel like you've got it, you may move on to the U-try section here. Right? And also at the same process right now, go ahead and pause your video. Right? Pause your video so that you can work on the U-try questions. And then once you've finished all 4 of the U-try questions, then come back, unpause your video, and then check your solutions with me. Okay, but once again, pause your video now, try the 4 questions on U-try, and then once you're finished, come back and check your answers with me on the video. Unpause it. All right, so welcome back. Hopefully you've had a chance to get all of those done, and now you're ready to check your solutions. All right, so you can see there on number 5, I got intersecting lines that intersect at 0, negative 2. On number 6, same thing, intersecting lines, they were at 3, negative 2. Number 7, once again, intersecting lines at negative 1, negative 1. And then finally, number 8, I got that these lines were parallel. So if they were parallel, then they had no solution. All right, if you got any of these incorrect, please go ahead and make sure you change your answer to make it match mine. And thanks for watching. Now you're going to have a classwork that you need to work on for the rest of the period to practice solving systems of equations by graphing.